Today we'll be solving problem 6 from the homework, which is proving that vector u cross vector v dotted with vector w is equivalent to the negative of vector v cross vector u dotted with vector w. The first step was to show this in component form. So we expanded everything to a summation notation using the component times each base vector of each of the vectors in the equation. So that gives us the result of this equation as the second line. So we further expanded this into each component of w over I from 1 to 3 times the result of the cross product of u and v. So you can see from line 3 that the result of that, the left side is equivalent to the right side with the exception of each of the cross product results being switched. So when we distribute the negative to each of the parentheses here, it switches back and makes the left side and the right side exactly equal.
Okay, so welcome back. Again, we're going to solve problem 6, which is this stated problem up here, but now we're going to use the summation to solve it. So we've just expanded it here into your basic expanded summation notation. And then this next line down here, the third line, we actually condense it so that it's easier to read. So we group all the summation terms together, then we group all the components together, and then what we're left over with are the base vectors in this form. And this is actually, we can recognize as the permutation. And we're going to take a second to talk about what the importance of the permutation actually is as it relates to all of the components. And so over on the left, we have a cyclic system, so that means that it follows the IJK convention. And that includes IJK, JKI, or KIJ. It's not important where you start, it's important that you're going in this clockwise direction. And in that case, the permutation is equal to 1. Now, if we have an acyclic system, where we go in the counterclockwise direction, so that includes IKJ, KIJ, or JIK, no matter where you start in there, the permutation is equal to -1. And so back to our original problem here, we can recognize that the permutation of JKI is equal to 1 on the left side here. And over on the right side, the permutation of IKJ is equal to -1. So now we have two negatives on the right side that cancel, and we end up with the equivalent statement, thus proving the original statement using summation.